So now we can take a look at what role subsequences have in convergence of other sequences, right? So it turns out if we have a sequence S sub n that converges to real number S, then every single subsequence of S sub n will also converge to S. Right? So whenever you have a sequence that converges to a real number, then no matter what subsequence you might choose, that subsequence has to converge to exactly the same number. Let's go through and try to prove this. Right? So let's let S sub n be a sequence of real numbers. With S sub n converging to S. Then, if we know that, what does our definition of convergence tell us? Well, it tells us given epsilon greater than 0, there exists a natural number n. So there exists this natural number n such that whenever little n is at least the value of big N, we have, or this implies, that the difference between S sub n and S is less than epsilon. So that's our definition of convergence. Note that for any k, so note that for any k, nk, n sub k greater than or equal to k. So we are going to have, whenever this value of k is at least the value of big N, we have n sub k is greater than or equal to k is greater than or equal to n, and so we end up with the absolute value of S sub n sub k minus S is less than epsilon. Right? So when we go further down in the sequence, no matter what subsequence S sub n sub k that we might choose, that subsequence has to converge to the same value of S. No matter what. Beautiful. Notice the contrapositive then would be if we have a subsequence that either diverges or we have two different subsequences that converge to different values, then we know that the value, the original sequence, has to diverge. So if there exists a subsequence that diverges or two different subsequences that converge to different values, then we know that our sequence, our original sequence, has to diverge. All right, we'll talk to you next time.